So we're a spin-off from Aalto University, founded in 2019, on a mission to commercialize novel and radical technology for the reduction of heat, water, and harmful chemicals for the utilization of biomass. The starting story, or the spark, initiated when our two Ollis meet each other, so Professor Olli Dahl and Olli Kakkonen, serial entrepreneur who has experience in international business and commercialization. We are today a diverse team, a multidisciplinary team with different background in chemical engineering and business development and design to really maximize the impact of our innovations. I will present here our technologies. We will start with AltoCell, that has been, let's say, the first incipit or the start of the company. So AltoCell technology was originally developed in Aalto University, but today Nordic Bioproducts Group is the owner of this technology. Is a process for the production of microcrystalline cellulose, product that probably most of you are familiar with. It presents itself as cellulose powder. It's a pure cellulose that it's commonly used in cosmetics, food, and pharma. The key aspect of AltoCell is that it utilizes kraft pulp for the production of this high-value product. And of course, the key differentiator here with many other processes for the production of MCC, microcrystalline cellulose, is the efficiency of the process. So because we are able to have so large energy savings, water consumption, and chemicals, we can guarantee that we have a product that has much lower carbon footprint regarding the MCC production. Now, because of the large savings and overall efficiency of the process, what we soon realized that we were not just able to target the current MCC market, so when we look at cosmetics or pharmaceutical and food, but really start looking at a whole new range of different applications, so really go and expanding the possible absorption of this product in different type of product applications. So we can start looking at applications that are more volume-driven, for instance, but also other type of value-driven applications that on that side of the spectrums. Now, next. So what we see here, and let's say that the great potential of this technology is that we can start looking at really expanding the potential application of MCC in many different areas, so expanding the potential of these products. Now, second technology that I'm presenting here today is Norratex. So this technology was announced publicly only a few months ago. It's a new process for the treatment and dissolution of cellulose, aiming to, of course, tackle the global issue of the textile problem that we're all facing. And of course, we wanted to take the know-how and all the experience that we have within the team for the cellulose treatment and processing to bring this technology to the market. Now we have, while we have announced this technology a few months back, we also announced our collaboration with CMPC to really take this technology forward. Now the key aspects of Norratex was that it was originally developed to be utilizing kraft pulp. So this is a more heterogeneous raw material than the traditional one that it's used, so the dissolving pulp. The fact that we are not utilizing carbon disulfide, so this harmful chemical that has been utilized in the past. And of course, we, since the beginning for deployment of the technology, to really start looking at a product that is very cost competitive. We have here some pictures for the overall look of the first samples. So we have both kneaded samples and filament. So of course we are at the beginning of this process. We have an ambitious path, but we're at the moment developing the fibers properties. We're developing the process itself. We have been really, let's say, surprised how smooth it went so far, in the sense that since the first test, the process went very smoothly. The fiber for fiber friction was really optimal in the beginning for the spinning process and dissolution and so on. Now, a very important aspect regarding AltoCell, but overall about our technologies, is the sugar utilization. So when we see this raw material, for instance, like the kraft pulp, but also when we start looking about different type of input materials, is the sugar let's say, the sugar fractions of these raw materials. So what we call the sugarose opportunities is regarding the fact that by utilizing the kraft pulp or alternative raw materials in our process, in our hydrolysis process, we are able to produce these MCC derivatives or Norratex fiber. So these, let's say, feasible products that has already existing market to justify the whole process. At the same time, we have these parallel products that is the sugar stream. So we have C5 and C6 sugar available in our hydrolysate that they present themselves as pure fractions, and so a side product for our process. Now, the fact that we have this material available, so this side product available, is actually quite a game changer for synthetic biology and biotechnology in general, because as we know, with synthetic biology, we can engineer strains or select strains for the production of wide variety of materials, for instance, platform chemicals, bioplastics, and more, starting from the sugars. Now, the fact that we have these sugars available, it can really, in a way, catalyze the implementation of different biotechnology innovation, because as we know, industrial biotechnology have been struggling a little bit with heterogeneous raw material because the biological efficiency is relatively low. So with Aalto Cell and with our hydrolysis process, we can, in a way, enable a larger implementation of these technologies. So what we see here, in a way, potentially happening is a new concept where we have thermochemistry aspects, so this on the left side, and biotechnology. So these two words that have been relatively distant, they could potentially join each other to enable the full implementation and really utilizing fully a biomass and by creating new products. So what we can envision is that utilizing different type of raw material, like of course kraft pulp is always present in our technology, but also looking at alternative raw materials that can be processed through thermochemistry and biotechnology to go and create a wide variety of products that can have their own existing market and solving, sustainability problems. Now, where are we located? So at the moment, we are placed actually not far away from Fat Lizard, for the one of you who had the dinner there yesterday. So just next to it, we have our facility called BIG, the Bioinnovation Garage. It's a 500 square meter where we have our R&D facilities. We are setting up our labs and we have our offices. At the same time, we are setting up our first pilot scale in Lappeenranta. In both of these areas, we will looking at extraction, hydrolysis, and potentially fermentation. So of course, in the lab scale in BIG, we are looking at running different R&D projects and onboarding different partners, while in the pilot scale facility, we're looking at scaling up Aalto Cell and our technologies. Now, so a bit to summarize, so what we envision here is potentially a new factory where we can utilize different sources of raw materials, and thanks to our technologies, we can create a wide variety of high-value products that can have different type of applications. Now, obviously, depending on the raw materials that we can utilize, that will unlock different type of product applications and overall justifying the feasibility of the process. So to conclude the speech, as a small call to action in a way, so we are currently setting up, starting, or running different R&D projects, and this is a little bit like an opportunity map in the sense that we really are open to discuss with several companies and parties to start looking at diverse type of raw materials and utilizing our technologies for the cellulose processing and for the sugar utilization to start looking at new solutions. As we all know, it needs a lot of synergy between companies and parties to really create the sustainability impact that we're all looking for. Thank you. Kiitos.
Thank you, Dario. Really interesting presentation. Okay. Still people are asleep online, but I won't let that worry us right now. Any questions for Dario? Is it all very, very clear what this new company are going to do? Please, it's a big competition left and right side here. I'm expecting you next.
Thank you very much for your presentation. I'm just simple question. Where does the sugar stream come from for the fermentation? Does it come from one of your core processes?
It's actually during the hydrolysis process, the hydrolysate, basically.
Right.
So it's output from the hydrolysis process. We have the hemicellulose part of the kraft pulp would be C5 and C6 sugars in the hydrolysate, yeah.
Okay, and these are in the small size, not in the polymer form, but in the oligomers or smaller?
No. So we're looking, so the Aalto cell process itself allows that hydrolysis. So we're looking at it also in the pilot scale, yeah.
Yeah, okay. Thank you.
Thank you.
Thank you, really good question.
So much fats are chocolate.
Thank you. I just quickly wanted to ask, your potential feedstocks are quite diverse, and
Yep.
so it seems like your process is kind of agnostic in terms of being able to operate pretty broadly. And that's actually a little bit unusual. And so can you comment on kind of what would be the limiting range for your feedstock? A lot of them don't have lignin, very much lignin in it, but outside of from that, can you?
Yeah, that's a very good question. So primarily the process has been developed for kraft pulp. So of course, in that case, the lignin has been removed. But when we talk about this opportunity map, so we are still at the stage where we're really testing the technology. So we're having positive results, and we're going forward in this process, right? Of course, we're looking at raw materials that has high cellulose content and high sugars content, but as well, again, how was illustrated in that sort of like opportunity map, it really depends. So we're really developing it and going forward with it, yeah.
Thank you.
So I can't give like, specifics like it needs to be this amount. It's an ongoing process, and so far it's going really well, yeah.
Excellent, thank you.
Kiitos.